Hello everyone, today we will talk about superconductors. Before I explain what they are, we have to understand a few basic concepts. First, when current passes through a material, let's say copper, or through a light bulb, energy is lost in forms of heat, light, etc. The amount of energy that is lost is largely based on the material these items are made of. However, experiments showed that resistivity of a material decreased with decreasing temperature and can be modeled by this graph. Even metals such as gold that are generally praised for its low electrical resistivity, decreasing its temperature closer and closer to absolute zero did not fully remove resistivity. However, in a brilliant experiment conducted by Dutch physicist Heike Kamerlingh-Onnes, he found that when the temperature of mercury was dropped to 4 degrees Kelvin, there was no apparent electrical resistance to mercury. Thus, he was credited for discovering the first superconductor. As this graph shows, at certain points, superconductors quickly drop in resistance as temperature decreases, unlike other metals. Soon after, other metals such as tin and aluminum were also discovered to have superconducting properties at low temperatures. As superconductors lack electrical resistance, they experience no power loss. This can be modeled using the equation power equals current squared times resistance, where if resistance equals 0, then power equals 0 regardless of the current. Furthermore, if we examine Ohm's law, V equals IR, it suggests that if resistance equals 0, then voltage also equals 0, meaning current can flow inside a superconductor forever regardless of the potential difference. Superconductivity of a material depends both on the temperature and the applied magnetic field it is in. Type 1 superconductors only have one critical value, the value of the magnitude of the magnetic field, after which point the material is not superconductive, while type 2 superconductors have two critical field values. However, between the first and the second critical field value, type 2 superconductors does not completely act like a type 1 superconductor. Superconductivity also depends on the critical current density, since current can create a magnetic field, as explained by Biot-Savart's law. Another key feature of superconductor is that it will not allow for a magnetic field to pass through. This is because in order to keep the net magnetic flux through the superconductor zero, it will create currents that will induce a field that is equivalent in magnitude to applied magnetic force. The resulting magnetic field through the superconductor is zero, and thus field lines appear to go around the superconductor. However, in type 2 superconductor, when they're in their mixture of superconductor and normal state, some field lines end up passing through. Regardless, this is referred to as the Meissner effect. Practical use of this can be seen on the maglev train. The train cars themselves are giant floating magnets on superconductors. If magnetic fields cannot pass through the superconductor, the train can hover over the track. This allows the maglev trains to travel incredibly fast as it experiences no friction. One biggest drawback of using superconductors is that their critical temperature value is extremely low. As of today, the highest critical temperature for a superconductor is found to be 77 Kelvin. However, this is far cry from room temperature. If one day we discover room temperature superconductors, we can use energy more efficiently, as there will be no power loss. Thank you.